Welcome, welcome, welcome. Here we go. All right, today it says we're going to talk about parent functions. Parent functions, right? Got it right here. So that's the topic. The date is the 4th of October. And here we go. What I'll do is right there on the side, I'll try and draw a picture of what these guys look like, but it does give you a description. So our first function is a constant function. I have this paper for you, but I don't want you to feel like you don't need to take notes because you have the paper in front of you. Constant function. A constant function just means y equals some number, okay? Or f of x equals some number. Perhaps it looks like f of x.
You said it equals some number?
Is -3, okay? We'll say f of x equals -3. So some function of x. So what it means is we have a graph that is a horizontal line running at -3 on the y-axis. Cool? That's all it means. So make a copy of that. I don't have a whole lot of space in the video, so I can, let's see where my hand is. Yeah, I can draw one right next to it too.
How'd you get those lights?
I'm sorry?
How'd you get the lights to
Turn
turn on?
off?
Yeah.
Yeah, I hit the light switch and the lights go off.
I thought the light switch was.
No, just this one. Just this one is the only one that stays on, the emergency light, and that's where I should have put the flag, but I messed up. Anyway, the identity function is basically y equals x or f of x equals x. You have seen this a million times. This is what you've dealt with in algebras 1 and 2, mostly algebra 1. It is our simplest form of that slope-intercept form, right? But there's no intercept. There's no c. So f of x, a function of x, is equal to that value of x. That just means we have a diagonal line where our output equals our input. So we have a dot here at 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, etc., etc. Okay? So it's a straight diagonal line.
That's
Okay.
identity function?
Say it again.
Is that identity function?
That is the identity function, yes. Did I not say it out loud?
Huh. You said that.
Just in my head. Sorry about that. You okay? Number 3, this is the one that you should have worked with a lot in Algebra 2. It was finding everything you could possibly find out about the quadratic. So here we go. This is what it looks like. So I guess I'll label these constant. Identity. And we'll say quadratic. Where f of x equals x squared. All right, we finally squared that term. And all this is a simple parabola. Remember what a parabola looks like?
No.
It's like that U shape,
Yeah.
right? Where it comes and just touches the origin there. Looks like you can still see it. Maybe I'll write on the other side for the other ones. There's only one that we're really going to ignore because I don't know, I have yet to find a good reason to use it in life.
Wait, what?
The bottom one, greatest integer function. We don't use that graph in real life very often. I haven't found a good example of that. So I'll mention it, but we don't test on it.
So when do you use it, sir, if you're not using it in real life?
I don't know. I'm trying to figure it out. I guess because your outputs could be whole numbers or integers, right? Then you could graph it that way, right? You can't have half a fish if you're looking at fish populations. You know, say you're talking about that tank and you're getting ready to breed a couple of fish. Okay, when we started, we had one fish, but then fish laid eggs and little fishies hatched, and then all of a sudden we have more fish, and then over time we'll get more and more and more fish. We'll have to, build a bigger tank, put them somewhere else, put them in a pond, what have you. It could possibly, it's the first time I've ever thought of something like that. So we can't have a partial. We're not looking for the space in between, we're looking for an actual number. But let's go ahead and talk about what a cubic function looks like. God bless you. God bless you again. Cubic function. And this one's kind of cool. You're going to see this a lot. We'll go cubic. F of x is x cubed. And I think we've talked about this a little bit, right? Do we talk about odd and even functions yet? I think it was briefly. Now we're really going to talk about odd and even functions. So a cubic function on the graph looks like this. Both ends pointing in opposite directions, cutting through the origin with a little bit of a wiggle. I gotta run.
Sure,
I gotta run. Hit the space bar.
No!
For God's sake. No! I gotta put in my stupid password.
So that's my new job, I think. I'll get to it. Whoever sits here is dedicated.
Yeah. I need a clicker. No, I should just move it just back and forth real fast. All right, so there's our cubic function. We have a picture of it. It's very pretty. And everything else, as our powers get bigger, the degree of the function gets larger and larger and larger. We can harken back. We can look at these guys more and more and more. So we don't go to higher degree functions and paint a picture of them in parent form because they end up looking like this or this in their parent form. So we don't talk about a function that's fourth degree or fifth degree. God bless you.
Thank you.
Because they end up looking a lot like these guys, just a little bit flatter in parent form. Square root function. Woo! All right, so here's square root. Square root. And it's just a graph. Just kind of stick it out that way. It looks like that. Flattens out.
You're good.
F of x equals root x. Good? Everything okay, Mr. Bolton? Mr. Bolton, I do my best to record as many of these classes as I can so that I can post them to Google Classroom. I'll invite you shortly to the Google Classroom. And then when I post it, at least you have something to study while you're trying to do your homework. If you could, that notebook I just gave you, if you could go ahead and try and copy down as much of this as possible so we can move on. Where'd it go? You put it in your bag? Did you put it away by mistake?
I didn't go out there.
All right, I got another one. Sean, did you lift it?
Oh,
Nah, I have another one.
so what's a quadrant?
Say it again.
What's a quadrant?
A quadrant?
Yeah.
It's one of the 4 sections of a, you're very welcome. Quadrant. These are all quadrants.
Oh,
And 1, 2, 3, 4. Ah, graph in the first quadrant. Yeah, that's our, thank you for reading it. Holy cow. Sokol didn't even read the definition. I just wanted to show you what it looked like.
Is that like a little flexor right there? A little flexor.
Let's not go too far. Reciprocal function. Oh. Reciprocal function. This is goofy looking. All right, f of x is equal to 1 over x. It can also be listed as f of x is equal to x to the negative 1. Same thing. Those two things are exactly the same. Exactly the same. That negative exponent makes it its reciprocal. That's a little reminder of what you knew from way back when. You guys even remember that?
nope.
Ages ago, right?
Yeah, of course.
It feels like years.
Yesterday feels like years
Yeah. Okay. Well, that I understand. So this guy goes like this. We have a double asymptote here. So when we talk about end behaviors, this function gets infinitely close if we're going, if the limit of this function as x approaches negative infinity, this gets infinitely close to 0. And same on this side, it gets infinitely close to 0. Why? Because we got a little 1 in that numerator. So it'll never get to 0. Now, when you graph it on Desmos, and you're way, way, way out to the right, or you're way, way, way out to the left, you're going to see it's going to go ahead and round to 0, but it never actually gets there. But we've seen that before. We've seen asymptotes before because we're all smart kids in here. Tight, I guess. And the last one I want to talk about is absolute value.
That's the last one.
So we got dash in the door.
That's the other
Wow.
Good morning, Mr. Dash. What may I do for you?
I was just checking if we might have a test today for physics.
So you came to interrupt my teaching to talk about
We don't.
physics. Why would I give you a test today? I can't.
And respectfully, sir,
I can't, man.
I
I can't. We haven't gone over the study guide yet.
Oh,
That would be mean. Well, maybe I should just to bother them.
Do it.
Nah, I can't. You guys know we have to review stuff before we take a test.
Imagine they say do that.
It's only fair,
I'll get it.
right? Yeah, it would drive you crazy, wouldn't it, Sean? Pop quizzes are different, right? That's, hey man, I'm gonna give you a quiz on something I just talked to you about. Let's see if you looked at it or thought about it over the break between when I saw you last. That I don't mind as much.
Sure.
So this absolute value function, a function of x equals the absolute value of x. And it looks a lot like this. F of x is equal to x, right? It looks a lot like the identity function, only we have a problem. The output is inside, so the input is inside absolute value, so we can't have a negative value come out, right?
True that, true that.
True dat. So, I'm such an old nerd. So it's just a V instead. It would have been that straight line, but we can't have any outputs that are negative. So if I put in a negative number, my output's gonna be positive. So it looks like a V. Cool? Those are they. It's a lot of stuff we've looked at so far.
Yeah.
How we doing?
We got word problems on the way.
It's a lot.
It's a lot. I don't expect you to have it cold, right? Like if I give you some sort of test on these functions, I'm going to ask you if you remember what they look like, right? Why would I just, all right, memorize this, you're done. That doesn't help you at all, does it? Try and relate it to something, perhaps, inputs and outputs, right?
Hey, sir,
That's
I have
our
a
job.
question.
Yeah, please.
Do you have like a pliers or anything that
I do.
I can?
Is it okay if
If
we
it
do
weighs-
one more thing and then we take a little break mentally?
Do I have your permission?
No.
Teach me how to do
No.
So
Thank you, though. Thank you for asking it. I appreciate
Okay.
it. Stay with us. Stay with us.
So-
It's a lot. I know. Stay with us. We're doing a lot.
So
Today's a big day. Yes.
for the problems, we're supposed to tell which one they are.
Those are.
So yeah, we're gonna see it. You want to see it in action? Let's see it in action.
Which one?
Well, let's find out. Uh-oh. Oh, it's. Did I run out of battery? Oh no, I ran out of battery. Oh, there it goes. Oh my gosh. Technology. Here's our friend. Okay,
You got shit right now.
let us, I'm gonna just erase my underlines here so we can see.
Absolute value was the last one. Thomas agreed.
Absolute value is the last one that we worked with in this class.
I'm gonna drink.
Okay, so here's our example.
I think so.
Without even looking at what the function is, right? What does that look like? Which one does that look like? Oh, it says it right there.
Cubic.
Cubic, it does look like cubic, doesn't it? I covered that up there, but forgot to cover it up over here. It says it, but yeah, it's a cubic function. All right, so we're gonna look at what characteristics this parent function of f of x equals x cubed. We're gonna look at the domain. The x is involved, right? If I put in to this function, right? If I put in 1,000, will I get something out? Can I cube 1,000 and get a real number? Yeah. Can I cube negative 1,000 and get out a real number? Yeah, I can. So my domain is everything, right? All real numbers. So my domain, oh, here's our set builder notation again, what you guys love, right? Domain, right? The value of x such that x is an element of all real numbers. That just means it's everything, right? And then the range, right? Do I get out values? Is it going in both directions infinitely? Yeah, you bet. So our range is all y is such that y is an element of real numbers. all real numbers. So we see that we can put in anything and get out something, right? Just goes and goes and goes. What else does it want to talk about? Domain, range, intercepts, right? This particular function, where does it cross the x-axis and the y-axis? Right there at the origin, right? At 0, 0, right? So my x-intercept is 0 and my y-intercept is 0, right? It just cuts right through here in the middle.
Yes, Lord.
So far, pretty boring, right?
Yes.
That's not super exciting. All right, what else have we talked about in this class? Symmetry. Ugh. If I fold it over this way, if I fold this side over here, and it would look like this, right? Are these right on top of each other? Are they exactly the same? No, they're going and one's going down, one's going up, right? If I did the same thing here and folded it up, this guy would end up looking like this, right?
Yeah.
Now, is this exactly on top of this? No, it's over here. But this one, if I, poop. It's so tough for me to draw. If I draw a diagonal like that, they really do end up being symmetrical because it's sort of a twist and fold. So they are symmetrical about the origin, right? It's symmetric about the origin, and it's an odd function. Oh my gosh.
For real?
It is an odd function.
I do that.
It's an odd function because if I put in a negative, I get out the negative version. Pretty cool, right? Because when you cube a negative number, what do you get out?
Negative.
A negative number. Duh. Right? That's so dumb. You guys are too smart for me. All right? Is this a continuous graph? Are there any jumps? Any discontinuities at all? No. It's continuous, right? Great. Look at all this stuff you've already learned that you don't even know you've learned. Sure.
How would I know? So continuous means it's just going on and on.
It just keeps going.
So
Like, remember we looked at continuity at a specific point, right? We said, hey, is it continuous through here? And you say, oh, well, yeah, sure. It just keeps going through here. There are no jumps or anything. But if I want to say, is this entire parent function continuous? Well, is there any place where you think it would suddenly stop? Yeah.
Yeah, because I seen on one of the papers that we had, I was looking at over somebody's answers that they got from class, and there was one of the graph that was continuous, and I was a little bit iffy on that. I mean,
Okay.
it's continuous because it looks continuous. I thought I had.
And it probably had a hole in it. It was probably the one with, can't remember, there was some sort of sum or difference down here. It might have been squared, something like that, with something like that. May have been something like that.
Yeah, probably.
Um,
That was on the last.
and if you put, no, it must have been like that. It was, if you put in that opposite of this number, we get 0 in the denominator, but all the other numbers give us some sort of value, right? The only value that would give us 0 in the denominator is that -1. So that's where that hole comes into play, that removable discontinuity. Cool?
yes, sir.
I remember that was on the quiz that I remember for sure. Cool. When we go left to right, and we don't talk about increasing or decreasing a lot until we get to calculus, we do need to know when a function is increasing or decreasing. But if we start to the left and draw along the line, am I going up or down? I'm going up, and then I turn, and then I go up, right? So this one, believe it or not, we are increasing. Oh, I hate the way they wrote that. Ew, gross. This is a constantly increasing function. I don't like the way they wrote that. But we do like this. Remember these bad boys? Our end behaviors, right? The limit of this function as x approaches negative infinity, what's happening on the graph? As we go farther and farther to your left, it's going down, right? So as we approach negative infinity, we get out negative infinity. On this function, as x approaches positive infinity, this bad boy's going up, therefore it's infinite. Beautiful. Oh, it says the graph is always increasing. Oh, thank goodness. Whoo! I got scared. Jeremiah, I got scared that they wrote something goofy on the paper. Good?
Yes, sir.
Awesome. Love it. This is tough stuff. This is not. Most of these graphs are brand new, right?
No.
Have you ever seen all these graphs before?
Yes.
Yeah. Some of them. I bet, Mr. Calix, I'll bet you've seen this graph here before. This absolute value graph, the V.
Oh, yeah.
You've probably seen the V. You've definitely seen the quadratic, the parabola. We worked with those last year, right? And the identity and the constant, right? So what's new? Like I just refamiliarized you with these and the absolute value and gave you 4 more to look at. 3 more to look at. Yeah, so that's not so bad. Learning 3 more types of graphs. Cool. All right. I'm going to switch to, I think, unless I do not have it. It's here. Say it's true.
That's a lot of paperwork.
Say it's
Oh.
true. Looky, looky, looky.
Calix.
Yes. Oh, I don't like transformations. We haven't gotten to transformations yet. All right, we'll talk about transformations.
It says star.
I didn't even know that.
It says star.
I drew that so long.
What says stop?
I drew Stauffenberg in that math. You're in leadership detail.
That is weird.
I was bored. I needed to Google. His class was too.
He's a pretty boring guy anyway. So.
I think I saw like the numbers.
Oh, this is cool. Let's go ahead and do this before I move on. Here's my function. My function is f of x equals x squared. Remember what that looks like? Look at your notes.
X equals
X squared. What does that look like? Quadratic.
Give me 2 seconds. Give me 2 seconds. Give me 1 second.
Cubic.
Nope.
It's the U parabola.
It is the parabola. All right. So let's talk about it. What's the domain of this function? What's the domain? Can I put in a really, really, really big negative number and get out a number? Yeah, it's all the way across, right? So my domain, let's go ahead and write it in interval notation. My domain is negative infinity to positive infinity. My range, oh, here's my trouble, right? Anything below here, part of this graph? No. Where does it start?
At 0.
At 0. Does it include the number 0? It does. So I need that bracket. I need that bracket to show that it includes 0. Stay with me, bud. Stay with me.
I'm still with you. Oh, wait. Thomas?
And this goes up infinitely, so my range is infinity. Okay?
Sure, so it's not possible to put a closed parentheses on the infinity sign.
No.
It just doesn't make sense.
So it's not an actual value.
Yeah, it doesn't make any sense.
It just means it continues on.
So if we were to write that on a test by accident, is that like completely wrong?
I can't wait to mark it wrong.
Yo.
I would be super excited.
Sir.
I would probably write, yippee!
Sir, what's up? Oh my.
Yippee!
That's the new X mark.
That's what my daughter says, so I like yippee. That and meow, I don't get the meow part. That's weird. Let's talk about the intercepts. Where does it cross the X and Y axis? Right there at the origin. So X and Y intercepts are at 0, right?
Yes.
Or you could give it a coordinate pair of 0, 0 if you want. I'm good with that. Is this a continuous function?
Yeah.
Any holes or anything in there? No jumping, right? No asymptotes. Great. Okay, it's continuous. Oh, now Sokol has to write continuous. Continuous. If I say it out loud, I remember to spell it correctly. I always forget a U in there somewhere. The end behavior, what are the ends doing?
They're gonna keep going.
They keep going.
They just keep going up, right?
So
So,
they keep increasing.
right, so the limit of this function as x approaches infinity is infinity, and the limit of this function as x approaches positive infinity is also positive infinity.
So if we don't write it with the equal sign, we put a comma. You don't mark that.
Failure!
I
Yippee!
got that wrong on the test.
Yippee! I won't take a lot of credit on it. I can't destroy your lives like that. I'm not being like that.
Someone reads.
So we're gonna keep doing stuff like this, so it'll eventually sink in. Okay. I did actually have an example of that on the board while you were taking that. Yes, sir.
How do you get that stuff?
Sure. Take the pass with you. One of those two things hanging there.
And that is
The bathroom pass.
So
Are
I'm
you
not
taking
taking
your
SAT
bag?
tomorrow. What questions am I using?
Just be able to use Desmos.
That's it?
Yeah, for your parabolas.
Okay.
You should be able to FOIL and factor. You have a reasonable knowledge of foiling and factoring. You just be good. No, there's no break time. This is a short class.
Sure, but isn't it shorter because it's digital though?
It depends.
They shorten.
So I am not going to give you any weekend homework.
Thank you.
Right? This is the end of. Oh, sorry, I missed something. I missed symmetry. Right? Symmetry. If I fold it over, right? If I fold this side over this, will it be right on top of it?
Yeah.
So it's symmetric about the y-axis, right? If I make the y-axis the center and fold it over, it's symmetric about the y-axis. So,
The axis is.
so if I fold it over this way,
It's not symmetrical.
I'm going to a different place, right? But if I fold it this way, this part sits on top of this part. So this is symmetric about the y-axis.